Hello everyone, my name is Amit Parmanti. So let's jump into today's geometrical question. It is given that if the ellipse x square by 4 plus y square equals to 1 meets the ellipse x square plus y square by a square equals to 1 in 4 distance points and a equals to b square minus 5b plus 7, then b doesn't lie on. So let's first understand what are the data given in the question. So if we're dealing with ellipse, let's first discuss the general formula of the ellipse. It is given that x square by a square plus y square by b square equals to 1. Yes, that is the general equation of the ellipse, this square. Now, what does this particular equation indicate? It indicates that this origin, which is horizontal axis length is A and vertical axis length is B, or I can say the particular ellipse is lying on the origin. Yes, so the center of the ellipse is lying on the origin if it is following x square by a square by y square by b square equals to 1, this particular formula. Yes, you can see the first, if I'm checking with the first ellipse, if I'm comparing with it, what I am getting? Yes, the same format. If I'm comparing the second ellipse with the given general equation, it is also following the same format. So from one thing that I can ensure is that both of the ellipses center lies on the origin. Clear? Now, let's first draw one particular ellipse. Yes, let me draw an ellipse of something like this. Yes, this is the origin. So let this ellipse be x square by 4 plus y square equals to 1. Correct? Now, what is the other ellipse? It is given that it is x square plus y square by a square equals to 1. Now, in this given equation, what I can see that the a value, or I can say the horizontal axis length square, which is 4 in this situation, and here it is 1. If I compare both of the horizontal values, let's say this is ellipse 1, which is E1, and this is ellipse 2, which is E2. I can say that for E1 is greater than E2 for horizontal length. Yes. That means if I'm drawing another ellipse, that ellipse horizontal length will be less than my current ellipse. Yes. So if I can draw, so in many particular ways, I can draw another ellipse which value will be less than 1. Yes, I can draw ellipse something like this. Also, I can draw an ellipse of, let's say, something like this. Yes, if I am drawing it down in one particular way, let's first understand with this particular ellipse. So this particular ellipse can be equals to this equation, which is x squared by 1 plus y squared by a square equal to 1. But if I am reducing the a value of this equation, what is happening? And in this correspondingly, if I'm reducing the y value, what is happening? In the new particular, you can say the inner ellipse is not touching, or you can say intersecting the outer ellipse on the 4 points. Yes, it is given that both of the ellipses are meeting each other at 4 distinct points. But if I'm following this type of structure, what is happening? You can see that both of the ellipses are not intersecting with each other. But let's say if I'm not considering this type of ellipse, instead of this, I'm considering an ellipse of something like this. Yes, in this ellipse also what is happening? The center is origin, but the major axis here is the, you can say, the vertical axis or the y-axis in this situation. Correct? Now, in this situation also what is happening? You can see there are 4 distinct points on which both of the ellipses are intersecting each other. Yes. So either the ellipse, the only possible situation for the ellipse where either it will be a horizontal one or it will be a vertical one. Yes. You are seeing that since it is given in the question that the a value will be less. So if I'm taking this particular equation and making the a value less, both of the ellipses are not touching each other. Yes. And other situation that can only possibly exist is this type of situation. In this type of situation, what is happening? You can see, according to also the question, the ellipses are intersecting each other at 4 distinct unique points. So one thing that I was able to know that the ellipse, the second ellipse will look something like this. Now I have to find out the each coordinates and find out whether I'm able to find out the a square value in this equation. Yes. So let's go to the next page and draw the structure in a perfect way and then try to understand. Clear? Okay. Now, I have drawn this particular structure here. You can see that both of the ellipses, the starting point is our origin, and you can see this particular length is a. Yes, if I compare with the original equation, it is given that x square by 4 plus y square equals to 1. And what is 4 here? 4 equals to a square. So a will be 2. Yes, what is 2? It is the absolute length. So this value is 2 and this value is also a. Correct? Now, what I have known, this is the type, this is the equation, you can say this is how the other graph will look like, or you can say x square plus y square by alpha square equals to 1. Now, this particular alpha, I am taking this as alpha because there are 2 particular rays. I'm talking this as alpha. Okay, now this alpha square, if I'm looking at it, what I can understand is that, okay, now from this, since the x square denominator is 1, this length will be also 1. Because why? Because the denominator of the x square, the root over of the denominator of the x square tells me the length of the major axis. In this situation, which is the major axis here, the x length is the minor axis and the y length is the major axis. So for the outer ellipse, this length will be how much? 1, correct? From the equation x square by y square by equals to 1. Since the coefficient, the denominator of x square is 1, this particular length will be also be 1. Clear? Now, for this particular equation, or you can say for the particular situation to exist, this you can say the major length, or you can say the y length from origin to the othermost equal point, which is 0 to a. This particular length, you can see what is a here, this is the alpha. Yes, so what is the denominator of y square? It is alpha square. That means this particular length is alpha. From here to here it is alpha, and from here to here it is also alpha. This one is clear. Now, for both of the ellipse to have an intersecting point, what I want this point 0 comma alpha to be above 0 comma 1. Yes, if this type of situation cannot exist, then there will be no more situation of 4 intersecting point. Yes, let's think of a situation. Let's say if the ellipse is like this, correct, and it is given that the new ellipse a value is less, that means it will look somewhere like this, correct? If this type of situation if exist, can there will be 4 distinct points? No. The only type of situation it can exist if it looks something like this. Yes, you can see there are 4 distinct points. But for this point, what I have to ensure that this particular point is like this particular point, let's mark it as x, and this point as y. X needs to be present above y. Yes. So what is the coordinate of x in this situation? This is 0 comma a, or I can say 0 comma alpha. And this particular coordinate is 0 comma 1. Clear? Why it is 0 comma 1? Because the outer ellipse is intersecting at this particular point. And this particular is for the minor axis for the outer ellipse. So what is the minor axis length? It is given in the equation. So it is x square by 4 square by 4 square by 1 square equals to 1. Yes. What is the denominator of y square? It is 1. That's why the minor axis length is 1. So from this observation, what I have concluded that for this particular situation to exist, I want 0 comma 1 to be below 0 comma alpha, or I can say that I want 0 comma alpha to be ahead of 0 comma 1. Clear? Or if I write it down in a much simpler way, this whole length is alpha and this whole length is a. I want alpha to be greater than 1. Clear? That is my particular equation. One thing that I have concluded is that if I want my both of the ellipses to intersect at 4 distinct points, my alpha should be greater than 1. Clear? You can see from this graph, we can observe that the ellipse will have 4 points of intersection if alpha is greater than 1. Now let's put this alpha in the given equation and try to find out where will the point B will lie. Clear? So in the equation, we have found out that alpha is greater than 1. And in the original equation, it has given that alpha equals to b square minus 5b plus 7. Yes, if I replace alpha with the 1, what I want b square minus 5b plus 7 should be greater than 1. Correct? Because if the alpha is greater than 1, then only it will be possible condition. And alpha is b square minus b plus 7. So b square minus b plus 7 should be greater than 1. Yes, let's take this 1 to the left hand side. So it will be b square minus 5b plus 6 greater than 0. If I factorize it, it will look something like b square minus 2b minus 3b plus 6 greater than 0. B, if I take as common, it will be b minus 2. If I take minus 3 as common, it will be b minus 2. If I factorize it, it will be b minus 2 into b minus 3. Yes. So if I plot all of these elements in the number line, all of the roots in the number line, the roots are 2 comma 3. So 2 comma 3. Now using the point graph system, positive, negative, positive. What is this positive, negative, positive sign? Indicating that if I take the x value between 2 and 3, the output will be negative. And if I take any value from minus infinity to 2 or 3 to infinity, the output of the function, this particular function will be how much? Greater than 1. So if I take any point between 3 to infinity or 2 to from minus infinity to 2, this value will give me a positive value. If I take any point between 2 to 3, I will get a negative value. And if I take the value 2 and 3, I will get the value as 0. I hope this was able to clear. So from this understanding, what I want the situation where the output will be greater than 0. Yes, from the equation b minus 2 into b minus 3 is greater than 0. And I can see that the particular value on which part it is greater than 0, from 3 to infinity. This part is above the x-axis, you can say, or towards the positive y-axis, and this particular point from minus infinity to 2 is what, above the x-axis. So if I find the union of this, it will be minus infinity to 2 union 3 to infinity, you can see, and with that our option C is our correct answer. So yeah, thank you, take care, and we will meet in the next class.